Oh, there's a song which is called Group 1.
Group 1? What's that? I don't really understand. Can you explain it?
You don't understand? Let's look at my teaching video, okay? So, whoosh.
The group 1 elements, which are known as alkali metals, are a bit different from most other metals. They include lithium, sodium, potassium, rubidium, cesium, and francium. Instead of being strong, having a high density, and having a high melting point, like you expect of a metal, the alkali metals are in fact relatively soft, with low densities and low melting points. They are also much more reactive than other metals, and react vigorously with water, oxygen, and group 7 elements such as chlorine, as we'll see later. As you go down the group, the elements become even more reactive, with cesium being so reactive that it can ignite spontaneously at room temperature. Another trend as you go down the group is that the melting points and the boiling points decrease. Now, an easy way to remember this trend in reactivity is that common table salt, which has sodium in it, doesn't just suddenly catch fire as you sprinkle it on your potatoes, whereas cesium probably would. Now, a big part of chemistry is explaining the properties and trends that we see. For example, how would you explain the fact that alkali metals are so reactive? Well, if you remember from our electron arrangement video, which we'll link down below, all atoms want to have a completely full outermost shell in order to be stable. And because the alkali metals are all in group 1, we know that they all have one electron in the outermost shell. So in order to react and be stable, all they need to do is lose that one single electron, which is pretty easy because there's only one electron to lose. And because they lose a 1 negative charge, they'll become a 1 positive ion. What about the trend that we mentioned though? That they become more reactive as you go down the group. Well, as you go down the group, the atom's radius gets bigger, and so the outermost shell gets further and further away from that positive nucleus. Now, as this positive nucleus is the only thing holding the outermost electron in place, the increased distance weakens the attractive force between our positive nucleus and that outer negative electron, meaning that the electron can be lost more easily, increasing the atom's reactivity. Remember, the term reactivity isn't anything special. It's just related to how easily atoms can lose.
Wait a minute!
Hello everyone, my name is Chris. Call me Teacher Chris. Today I'm going to teach one of the chemistry topics, which is elements in group 1.
At the end of the lesson, students should be able to generalize the changes in physical properties of element when going down group 1. Next, students should be able to generalize the change of reactivity of elements when going down group 1. Lastly, the students should be able to reason out the physical and chemical properties of the other elements in group 1.
Alkali metals, or group 1, are 6 chemical elements in the leftmost column in the periodic table. They are lithium, sodium, potassium, rubidium, cesium, and francium. Like the other elements in group 1, hydrogen has 1 electron in its outermost shell, but it is not classed as an alkali metal since it is not metal but a gas at a room temperature. On my right side shows the uses of several group 1 elements, which are lithium, sodium, and potassium. For example, lithium is widely used in battery production. Lithium batteries power all modern electronics, electric vehicles, and most things that need electric powers. Next, sodium is used in street vapor lamp. Lastly, potassium is a vital component of fertilizer and has a major role in the daily functioning of the human body also. Potassium is also used to make detergent. So that's the uses of this element. What are the uses of this element that you know? Let me know what you think. Now we move on to changes in physical properties of element in group 1. Generally, atomic radius always increases down the group, and this is true for ions as well. Down any group, the number of electrons surrounding the atom increases, and this also means that the number of shell of electrons surrounding the atom also increases. Therefore, down the group, the atomic radius increases. This is the repulsion that occurs between shells of electron. As the number of shells increases, so does the number of negative charge surrounding the positive nucleus. Thus, the amount of repulsion between shells also increases as the number of the electron and shell increases. Basically, group 1 elements have low melting point and boiling point if compared to other metals like iron that have a melting point of 1540 degrees Celsius and boiling point of 2760 degrees Celsius.
Teacher, I have a question. Why do the melting point and boiling point of elements decrease when going down the group?
Good question, Christine. The answer is the increase in the atomic size down the group will weaken the attraction force between the atom. Therefore, less heat energy is required to overcome the attraction force between the metal atoms. Now, do you understand, Christine?
Yes, teacher.
Good. Now, move on to the next part. This diagram shows the reactivity of elements increases when going down group 1. Why does the changes occur, The answer is the reactivity of alkali metal in group 1 is due to the tendency of an atom to donate its valence electron. The number of shells filled with electron increases when going down group 1. This causes the increases in atomic size. The position of valence electron is placed further away from the nucleus of an atom. When the nucleus attraction force towards the valence electron weakens, the electrons are more easily donated. Now you have studied the properties of lithium, sodium, and potassium. But how about the properties of other metals, such as rubidium, cesium, and francium? Like other alkali metal, rubidium, cesium, and francium elements are soft metal with shiny surface and have low melting point and boiling point. Rubidium and cesium are metals that are very reactive and burn quickly. Rubidium and cesium usually are combined or react with other elements. Thus, they are very difficult to be isolated chemically. For francium, francium element is an unstable radioactive isotope with a short half-life. All three elements are very reactive with water and oxygen. So students, that's everything you need to know about group 1, which is alkali metal. So I will see you on next lesson. So goodbye.